Hi, everybody. In this next section, we're going to look at graphing polar equations. So we've already talked about how to plot polar coordinates, and now we're going to go to the full equation and how to actually graph them. So just remember first that a polar equation has variables r and theta instead. And what you do is you actually graph on a polar grid. So here's a drawing of it. It's not perfectly to scale, so bear with me. I didn't use a protractor here. I just kind of did it by hand, but you get the basic idea. We've seen this before, right? So you still have that regular plane that we're used to, but remember that our values here are angles instead. So this would be the angle 0, pi over 2, pi, 3 pi over 2, and then you can see I put the other main angles in between. So you have pi over 6, pi over 4, pi over 3, etc., all the way around that circle back to 0 or 2 pi. And then what happens here is you have your r. So you have your initial radius of 1, of 2, of 3, and so on. So remember that r is how far along you are, kind of basically down that radius. And this is what it would look like. Now, again, it's not the most perfect picture, but hopefully you get the idea of what a polar grid looks like. So this is what we're going to be graphing on. So we're going to start with the example. We're going to graph r equals 4 cosine theta, and theta will be in radians. And we kind of start the same way that we would do a normal graphing problem, is we would just start by making a table. That's one way to do it. So we're still going to use plotting points method here. In this example, and just like you would think like you do with a regular graph, we're going to make a table of points. So here, and I have a lot of the work pre-done just to save some time in the video, but you're going to be plugging in your theta for your x. So this is your input, and then your output, like your y, would be the r instead. So r equals 4 cosine theta. Now, the other thing I'm going to do is I'm going to look at my polar grid, and I do notice that I go, I have pi over 6, pi over 4, pi over 3, pi over 2, etc., all the way around. So I really want to stick with these as key points. You don't have to do every single one of them. I'm going to go by pi over 6s here. It's a pretty small angle. So I'll do pi over 6 and then pi over 3, 2 pi over 3, etc. But if you want to fill in with pi over 4 and pi over 2, you could do all, we're going to do a lot of those as well here. Maybe not every single one, but we're going to do a lot of them. So you want to kind of stick to these angles here. All right, so I'm going to start with 0, and I'm just going to go ahead and plug in 0 for my theta. So you want to remember your values. This is a good time to take out your table of sine and cosine values if you have one made. So cosine of 0 is 1. So 4 times 1 is just 4. So my first point is going to be 0, 4 there. Oh, sorry, 4, 0. Remember, when we're plotting our polar coordinates, the r comes first. So even though I wrote it like this, the r is going to be first here. It's just easier to set up your table this way instead. All right, I'm going to do pi over 6 next. And again, when I plug in values here, I really probably want to use my common values, right? I don't want to have to be doing too much extra work. I want to keep it as easy as possible. So cosine of pi over 6 is root 3 over 2. So here I could do 4 over 2 is 2. This becomes 2 times root 3. And then for graphing, you probably want the decimal version here. So I would just plug this into my calculator and I get about 3.5. And again, it just helps us with graphing. I don't really know what 2 root 3 is off the top of my head. So for graphing purposes by hand, the decimal is going to be helpful there. All right, I'm going to keep moving by multiples of pi over 6 in this case. So my next one would be 2 times pi over 6, so that would give me pi over 3. So cosine of pi over 3 is 1/2, so this becomes 2. So I have 2 pi over 3. And then my next one is going to be pi over 2. Now, cosine of pi over 2 is 0. So I would have 0 pi over 2 here. Next, I'm going to go to 2 pi over 3. Cosine of 2 pi over 3 is negative 1/2. So I get negative 2. Next will be 5 pi over 6. And cosine of 5 pi over 6 is negative root 3 over 2. Again, those 2's will cancel, so I have negative 2 root 2, or about negative 2 root 3, excuse me, negative 3.5. And then I'm going to do pi. And cosine of pi is negative 1. So I have negative 4 there. All right, so I'm going to stop here. What's going to happen if you keep going, and again, I've already done some of this work out to save some time on the video, is that you actually keep repeating at this point. So I've gone through basically these points here. So I am doing pi over 6 as my main kind of angle here, and just using multiples of that. So pi over 6, pi over 3, 2 pi over 3, 5 pi over 6. But it is good to also put those axes values in there. So I did skip pi over 4, but you could do that one if you wanted to. I did skip 3 pi over 4, but again, you could do that one as well. But I did include 0, pi over 2, and pi. And then what happens here is you will notice that you'll get kind of keep repeating values if you keep going. So I do encourage you, you can keep going here and try some more values, and you're going to start to see repeats. So now what I'm going to do is I'm going to graph this. And to save a little time, again, I'm going to use the graph above here. So I don't have to redraw it. And I'm going to start plotting my points. So again, you just want to be a little bit careful. Remember, we're talking about the polar grid here. So we're not in the XY plane, we're in the polar grid plane. So we're going to go ahead and graph those. So my first one is 4, 0. And I'm going to do this in pink. So let's see, I went out 1, 2, 3. I do need to go out one more circle here. Right. And the reason I went out one more circle is because my R is 4. So I want to be going out 1, 2, 3, 4 units there along those circles. And my angle was 0. So my 0 angle is here, and this is my point 4 is 0. All right, so my next point is 3.5 pi over 6. So here's my pi over 6 angle. I'm going out 3.5. So 1, 2, 3.5. And then I have 2 pi over 3. So here's my pi over 3, and I'm going up 2, 1, 2. And then I'm looking at 0 pi over 2. So if my value is 0 here, it's going to be right on that origin at the center. Just kind of try to draw that in there a little bit. All right, and let's see. Next, I have negative 2, 2 pi over 3. So 2 pi over 3 is here. But remember, because it's a negative 2, we're actually going opposite of that. So we're going down to 5 pi over 3, and I'm going 1, 2. So this would be negative 2 at 2 pi over 3. My next value is negative 3.5, 5 pi over 6. So again, here's 5 pi over 6, but because the R is negative, we're going opposite that. So negative 3.5, 1, 2, 3.5. And then my last value here is negative 4 pi. And so here's my pi angle. And again, because the 4 is negative, it's going the other side. So 1, 2, 3, 4. So you're actually back here again, and you can see the repeating. It does help when you're making the table to plot the points as you go along. So then that way you can start to see, you know, if you head back to where you were, you're going to start to see like a repeat going on there, and just will help you. I decided to do the table first and do a few points first. But again, once you have a few points, stop, kind of plot them, see where you are. And if you start to see the repeating, you don't have to keep going and going. You can realize that you can stop. And now what you're going to do is you're going to connect the dots. Keep in mind, I do this by hand. So it really doesn't look very good. I'll show you what it looks like in the book in a second. But it's supposed to be a circle. So that is my picture here. And again, it's pretty hard to draw these by hand, particularly if you're not using a protractor and being really careful with your angles and your different circles coming outward as well. But you do get a circle for your graph. And I'll just show you real quick in the book, or so you can see the picture. So here's a nice, you know, computerized picture, and you can see that circle much clearer. It looks a little bit more in proportion there as you go around. Now, not to run away from this example just yet, I do want to point out that you can check that. So you're looking at it, you maybe say, hey, it really looks like it's a circle. How do I check that it is a circle? And what you can do is you could always go back to our standard form for equations, right? Using the rectangular coordinate system. So that's what we can do here. So I have r equals 4r cosine theta. That was my original equation I just started with. I could square, or not square, I could multiply both sides by r. So I'd have r squared equals 4r sine theta instead. Remember that r squared is x squared plus y squared. And then what happens is r cosine theta becomes x. So the 4 comes down, and then the r cosine theta becomes x. Now, this is stuff we did in our last set of videos. So if you forget how to convert between the equation forms, you want to go back and review the previous set of videos that we watched. So r squared is x squared plus y squared. Those are equivalent. And r cosine theta is the equivalent of x. So that's why I'm making those changes over. And the first step was just a little bit of algebra manipulation there. All right, so let's bring everything to one side. Subtract that 4x. And then what you can do here is you can go ahead and use completing the square. And what you'll get is the following: x minus 2 squared plus y squared is equal to 2 squared. So this gives us a form of an equation that we can use. So what you have here is x minus h squared plus y minus k squared is equal to r squared. So what we're seeing here is that our r is 2. So our radius of the circle would be 2. And then your hk is that center. So the hk would be 2, 0 in this case because there is no k. So this is your center. And if I go back to my picture on the page before, again, it's a little bit it's by hand, so it's not great. But that center, you know, would be right here, which looks pretty good at, you know, I'm going out 2 units, 0. And then you do see that radius of 2, right? 2, 2. So you do have that center at 2, 0, and you do have a radius of 2 there for that circle. So it does make sense, and it matches with what we would see in the XY plane there. So one thing to note, so you don't have to check this every single time, circles in the polar coordinate system look like this. So if it's r equals a cosine theta, or r equals a sine theta, and then our a would be greater than 0 in that case. These are both circles. So in the first case here, This would be your 0, your pi over 2, your pi, your 3 pi over 2. Your circle looks like this. Again, that's supposed to be a circle, so bear with me a little bit there. It looks more like an oval here. But this would be the A piece there. That's how it comes into account. Basically, like how far out it goes, how many units out that it goes. And then for your other one, your circle, again, bear with me here, would be up this way. And then this would represent the A, so it's how tall it goes instead. So these are what your circles look like, what those equations look like in the polar coordinate system.